What if I told you you could take a $15 copper pipe, bend it into a pyramid shape, and change how plants grow without adding anything to the soil? No fertilizer, no electricity, no chemicals. And yet, seeds may sprout faster, roots may grow deeper, and in some cases, yields increase. Now, before you dismiss this completely, that reaction is exactly where most people start. Because this idea sits right on the edge between something that sounds impossible and something that has been quietly tested for decades. And here's the part that made me stop. Some of these effects have actually been measured, not explained, not fully understood, but observed enough times to raise a serious question. So instead of asking, "Is this real?" we're going to ask something much more useful. What exactly is changing in that environment? Picture this. You walk into your garden one morning, same soil, same seeds, same conditions. A few days ago, you placed something unusual over one bed, a simple copper structure shaped like a pyramid. At first, nothing looks different. But then something small shifts. One seed breaks the surface earlier than expected. Then another. Then another. Within days, you start noticing a pattern. The plants under the structure aren't just growing. They're growing differently. Roots push deeper into the soil. Stems look thicker. Growth feels more directional, less random. And this is where it gets interesting. Some growers report that young plants don't just grow upward. They seem to orient themselves toward the structure above them. Now, this doesn't happen everywhere, and not every setup produces dramatic results. But in controlled comparisons, under otherwise identical conditions, some agronomists have measured higher yields, and in a few cases, the difference wasn't subtle. So now, you're left with a problem. Because if nothing else changed, not the soil, not the seeds, not the water, then what did? And this is where the story takes a turn most people don't expect, because it doesn't actually start with plants. It starts with a claim that sounded so unlikely, it was almost dismissed immediately. In 1949, a Czech engineer named Karel Drbal walked into a patent office with a strange idea. He proposed that a specific geometric structure, built with precise proportions, could influence physical processes without any external energy input. No electricity, no chemicals, no moving parts, just shape. At first, it sounded absurd, so instead of trying to convince people, he did something much more effective. He tested it over and over again, under controlled conditions, repeating the same setup. Eventually, the patent office agreed to test it themselves. And this is where things stopped being theoretical, because while the results were controversial, they weren't random. They were consistent enough to raise a much bigger question. If structure alone can influence matter, what else could it be influencing that we simply don't measure yet? Now, here's where it becomes less abstract. The shape used in these experiments wasn't chosen randomly. It follows the proportions of the Great Pyramid, with an angle of about 51 degrees. But what matters isn't the math itself. It's where this pattern shows up. Because similar proportions appear again and again in nature. In how plants arrange their leaves, in how branches spread toward light, in how roots expand into the soil. Not perfectly, but often enough to suggest something important. Living systems tend to organize themselves in efficient patterns. So instead of focusing on formulas, the better question is this. What happens when you place a structure into growing environment that follows similar patterns to how plants already grow? Because if plants respond to structure, then the space around them might matter more than we think. Now take that same structure and build it out of copper. One of the most conductive materials we use. Copper doesn't just sit there. It interacts with electrical fields, with moisture, with ion exchange in the soil. It's used in wiring, antennas, transformers, because it responds to energy. So now something subtle changes. This is no longer just geometry. It becomes a conductive structure interacting with its surroundings. And when you place that over soil, you're not just adding an object. You may be changing the conditions in which plants grow. Not in an obvious way, not instantly visible, but at a level where biological systems are extremely sensitive. And once you see it that way, you stop asking, "Is this real?" and start asking, "What exactly is this interacting with?" In the 1970s, a farmer named Les Brown built a full pyramid-shaped greenhouse. Not a small model, a complete structure. Then he started growing crops inside. And this is where things became harder to ignore. Plants grew faster. Yields increased. Overall, plant health improved. Now, not every observation was easy to explain. Food stored inside the structure didn't always decay the same way. In some cases, it dehydrated instead of rotting. And while not all of these results have been consistently reproduced, they raised a serious question. Is something about the environment inside the structure changing biological processes? Let's be clear, a lot of this is debated, but there are measurable observations. Studies have reported improved seed germination, changes in water behavior, accelerated chemical reactions. In one experiment, hydrogen peroxide broke down significantly faster inside a pyramid structure. That's not belief. That's a chemical reaction changing speed under controlled conditions. The interpretation is still debated, but the effect itself has been observed. More recently, experiments with crops like potatoes have shown differences in yield under controlled conditions. Same soil, same seeds, same environment, only one variable changed, the structure above them. And that's where a new term appears: electroculture, using natural electrical interactions to influence plant growth. Now here's where everything connects, because the pyramid alone is interesting, but it's not the full picture. At its simplest, two things are happening: interaction in the soil and interaction in the air around it. When you combine the structure with natural elements, like decomposing organic matter, carbon-rich materials like biochar, you start to see a pattern, not a complicated system, but a subtle shift in how the environment behaves. For example, microbial activity can increase. Moisture can be retained differently. Nutrients can move more efficiently through the soil, and roots respond to that. They grow where conditions are better. So instead of thinking about this as adding energy, it may be more accurate to think of it as changing how existing processes flow, not forced, not externally powered, just slightly redirected. And once you see it that way, it stops looking like a trick and starts looking like a process. Here's the uncomfortable part. Electroculture was studied in the early 1900s, documented, tested. Then it faded away. Around the same time, industrial fertilizer systems expanded rapidly. Today, it's a massive global market, built on continuous input. A system you build once doesn't fit that model, and that doesn't prove anything. But it does explain something: why ideas like this don't spread easily. Let's be clear, this isn't magic. It's not universally proven, and not every setup works the same way. But there's enough evidence to ask a serious question. What if plant growth isn't only about what we add, but also about the conditions we create? Because if even part of this is real, then something as simple as structure could fundamentally change how we think about growing food. If this made you rethink what's possible, send this to someone who grows anything, because the fastest way to understand an idea like this isn't to argue about it, it's to test it.